Very good morning, all of you. Can you hear me? Tell me. मेरी आवाज आप लोगों को आ रही है? बोलो जल्दी से, नहीं तो मुझे सेटिंग करनी पड़ेगी. ठीक है? So, okay, Alan and Omkar is saying yes, sir. Okay. So, we are at the end of this chapter, that is chemical kinetics. ठीक है? Today we will solve some numerical based on first order reaction, second order reactions. We will see some formulas also, because to solve a problem you should know the formula. So formula is very important while solving the problems, and you have to remember that formula. ठीक है, आप लोगों को क्या करने पड़ेंगे, जो भी फॉर्मूले फर्स्ट ऑर्डर के, सेकंड ऑर्डर के, हाउ टू फाइंड आउट रेट, हाउ टू फाइंड आउट ऑर्डर ऑफ रिएक्शन, हाउ टू फाइंड आउट टी हाफ, और हाउ टू फाइंड आउट particular time so as to particular reaction get complete to 50%, 70%, 80%, 90%. So different formulas are there, or one formula is there and you have to rearrange the formula according to the your problem. ठीक है, आपका जो भी प्रॉब्लम होगा उस हिसाब से आप लोगों को क्या करने पड़ेंगे, फॉर्मूलाज रीअरेंज करने पड़ेंगे. फॉर एग्जांपल, यू हैव टू फाइंड आउट द रेट कांस्टेंट, देन द यू हैव टू, एंड यू हैव गिवन टी हाफ. So by using T half also you can find out the rate constant. So I have to rearrange the formulas for T half. ठीक है, जो भी T half का फॉर्मूला है वो आपको rearrange करना पड़ेगा according to your demand. ठीक है. So in the last lecture we have seen energy of activation, how to find out the energy of activation. Two different methods are there and we have solved two examples. ठीक है, एनर्जी ऑफ एक्टिवेशन कैसे फाइंड आउट करते हैं. टुडे वी विल सॉल्व द न्यूमेरिकल बेस्ड ऑन फर्स्ट ऑर्डर रिएक्शन एंड सेकंड ऑर्डर रिएक्शन. ठीक है, फॉर दैट सम फॉर्मूलाज आर देयर. वी विल सी फॉर्मूलाज एंड एग्जांपल एट द सेम टाइम्स. वी विल सेव आवर टाइम्स. हम लोग क्या करेंगे, फॉर्मूला जो कुछ भी है वो एग्जांपल के वक्त ही वो डिस्कस करेंगे. ठीक है. सो लेट अस स्टार्ट टुडेज लेक्चर. इफ यू हैव आप लोगों ने अभी तक पेन नोटबुक नहीं लिया है तो टेक पेन एंड नोटबुक. ठीक है. So this is your lecture number 7 of chemical kinetics, and today we will discuss some numericals based on chemical kinetics, that is zero order reaction, first order reaction and second order reactions. And in the next lecture we will see probability factor and transition state theory. So within one lecture, except today's lecture, आज का lecture छोड़ के एक lecture में we will finish this chapter and then we will start with the adsorption. ठीक है, surface phenomenon that we will start in the maybe in next week. ठीक है. Okay, चलो, so let us start the today's lecture. Today we will solve the numericals of chemical kinetics. ठीक है, and the problem number 1. If you have, आप लोगों ने पेन नोटबुक लिया है, so write down this problem number 1. Problem number 1, that is a solution of H2O2 when titrated against KMnO4. So titration is there. Problem is based on the titration. Titration of KMnO4 versus H2O2 was performed at a different time interval. ठीक है. So first write down the problem, then we will discuss the problem. First we will understand the problem and then we will solve it. A solution of H2O2, a solution of H2O2 when titrated against KMnO4 at different time interval which gave the following results. ठीक है, तो क्या किया है, one titration was performed. That titration is H2O2 versus KMnO4 and the results are tabulated in this table. So this time is given, that is time small t in minutes is given, and volume of KMnO4 used for 10 ml of H2O2 is given. So in each reading we have taken 10 ml of H2O2, and to neutralize that H2O2 the volume of KMnO4 is used is given, that is 23.8 is given, 14.7 is given and 9.1 is given. So at zero time volume of KMnO4 use is 23.8. at after 10 minutes the time volume of KNO4 used is given, that is 14.7, and after 20 minutes volume of KNO4 is given as 19.1 ml, and you have asked show that the reaction is first order, and you have asked you have to show the reaction is first order. So how will you show this reaction is first order or not? Any order of reaction and not about first order. So you have given time at a different time interval, say at 10 minutes and 20 minutes. So first what you have to do, you have to find out a rate constant. You have to find out rate constant at 10 minutes, rate constant at 20 minutes. So क्या करना है आप लोगों को, first you have to find out the rate constant K1. Let us, we will assume this is a first order reaction, so I have written it K1. So you have to find out a rate constant K1 at 10 minutes. ठीक है, for example let it be x. ठीक है, x10, let I will say it is as a x10. ठीक है, then again we have to find out rate constant. So it is first order reaction, we will assume it first order reaction, that is K1 at 20 minutes, and let it be x10. Whatever the value we will get, we will call it as x. So it is at time 10. So rate constant, it is a value of rate constant, it is a value of rate constant at 10 minutes, and it is value of rate constant at 20 minutes, and we have to compare this value x10 and x20, we have to compare, and if these two value they are nearly same or they are similar, then we can say that the order of reaction is first order, because of first order का जो equation है वो equation वो उसके लिए applicable है. So अगर वो applicable है तो it is a first order reaction, then and then only we can say that the reaction is first order. When we can say that the reaction is first order, first we have to calculate the rate constant at different times, and after calculating the rate constant you have to compare the values, and if these values they are same, then we can say that the reaction is first order. So your job is what is your job? First you have to find out the rate constant. ठीक है, so in solution, so first we will write what you have given. So आप लोगों को क्या दिया है, write down this. At t is equal to 0 time, volume of KMnO4 is equivalent to 10 ml of H2O2, because here at t time means reaction ही start नहीं हुआ है, हम लोगों ने titration ही start नहीं किया है, that is a 0 time or t is equal to 0 time, which is equivalent to the solution 10 ml of H2O solution, that is 23.8 ml is considered as the initial concentration of H2O2. So initial concentration of H2O2, here I will write initial concentration A is considered as 23.8 ml. So your initial concentration is 23.8 ml. A is your 23.8 ml because that is at a 0 time. Then the next is at time t is equal to 10 and 20 minutes. Now here two time is given, at time 10 minutes and at time 20 minutes. Okay, so at a time t 10 and 20 minutes, volume equivalent to 10 ml of H2O2 are considered as a concentration of H2O2 left unreacted. Now we have to find out the volume of H2O2 which is left unreacted at a time 20 and at a time 10. Okay, we have to find out the unreacted volume. That means you have to find out the A minus 8 at a time 10 and at a time 20. So how will you find out A minus X at a time 10? See here. A is now we have considered it as 23.8. Now how will you find out when t is equal to 10 ml? A minus X is 17.4 because here it is given. Okay, and at a time t is equal to 20, A minus X is 9.1. Okay, so A minus X at a time 10 is 14.7 and A minus X at a time 20 is 19.1 and A is 23.8. Now you know the equation, which is very famous equation, K1 is equal to, this is a integrated rate law equation for first order reaction. K1 is equal to 2.303 T. This T is given to you and you have to find out the rate constant, log A by A minus X. Now A is known to you, A is 23.8 and A minus x at a time, a minus x at a time 10. Let us consider this is for t is equal to 10. Let us consider this is equal for t is equal to 10. Then a minus x is how much? कितना था a minus x? A minus x for a minus x at a time 10 कितना था? Tell me. A minus x at a time 10 is how much? I have told you. कितना था? A minus x 17.4. Correct. Very good. Kanishk. It is 17.4. So we will put this value. We will put this value. कितना था? 17.4 था. Correct. Istesham. So we will put this value. A you know, a minus x is you know, t is you know, and you have to find out the k1. So we will put this value k1. So k1 at t is equal to 10 minute. K1 as t is equal to 10 minute. Here we will put 2.303 divided by 10. 10 is how much? 10 is, sorry, t is 10 here, into log of a is 23.8 divided by a minus x is 14.7. A minus x is 14.7. Now what you have to do? You have to divide this, and after dividing you will get 2.303 divided by 10. It will come 2.2303, and after dividing this you will get 1.6190. 1.690. Take a log of 1.690 and tell me the value. Log of 1.6190 कितनी आ रही है value? We will multiply this value with 0.2303. कितनी आ रही है? Log of 1.6190. Let me calculate first. Log of 1. कितनी आ रही है? करेक्ट इस्तेशाम 0. कितनी आ रही है? 0.2092. If you multiply these two value, you will get 4.81 into 10 to the power minus 2 per minute. This is the rate constant at time 10. This is the rate constant at time 10. That is 4.81 into 10 to the power minus 4 per minute. Why per minute? Because the time is given in minute. Why per minute? Unit is why per minute? Because time is given in minute. So you have to give the unit to the rate constant as a per minute. So this is for first. Then we will calculate for k1. K1 at t is equal to 20 minute. So we will put this value 2.303 divided by 20 into log of 23.8 divided by कितनी थी ये वैल्यू? डिवाइडेड बाय 9.1. It is 9.1. Now we will solve this. So 2.303 divided by 20 will come as a 0.115. Then log of, if you divide 23.8 by 9.1, कितना आ रहा है? 23.8 divided by 9.1, 2.615. ये आ रहा है 2.615. Take a log of 2.615. Log of 2.615, 0.4174. So 0.115 multiplied by 0.4174. And if you multiply these two values, 0.115 multiplied by 0.4174, it will come 4.80 into 10 to the power minus 2 per minute. per minute. And if you compare these two value 4.81 into 10 to the power minus 2 and this value 4.81, they are same. They are same. कैसे हो? They are same. So the rate constant at different time interval, rate constant at different time interval is same. और मैंने आप लोगों को पहले बोला था अगर वो सेम आ रहे then we can say that the order of reaction is 1 because we have applied this formula, that is first order rate constant formula, to this reaction, to this data. So अगर ये सेम है 4.81 into 10 to the power minus 2 and 4.80, they are nearly same, so we can say that the order of reaction is 1. So by comparing, so what in the last conclusion after doing these calculations we have write one sentence: by comparing rate constant at two different time interval, we can say that the order of reaction is 1. We can say that the order of reaction is 1. Correct? ठीक है? Understood this problem? Then we will go to the next problem. समजले का सगळ्यांना हा problem? At the end you have to write down one sentence: rate constant at two different time intervals, they are nearly same, so therefore we can say that order of reaction is first order. Therefore we can say that order of reaction is first order. Why we can say that? Because we have applied the formula of first order reaction. We have applied the formula of first order reaction, then and then only we can say that the order is 1 for this reaction. ठीक है? Okay. Then we will see the problem number 2. आपके स्क्रीन पे problem number 2. क्या है problem number? Write down this problem number. Problem 2. For a certain reaction. Now here reaction name is not given. ठीक है? Reaction कौन सी है? It is not given in this case. Just they have said for a certain reaction of first order, but order is given. Order of this reaction is first order. 50% reaction is completed in 10 minutes. क्या है? What you have given? For a certain reaction 50% reaction is completed in 100 minutes. Sorry, 50% reaction is completed in 100 minutes. How long it will take to convert 90% reactant into the product? Now you have given a time, that is at 100 minutes, 50% of reactant converts into the product. ठीक है? At 100 minutes 50% of reactant is get converted into the product. Now you are asked how long it will take to convert 90% reactant into the product. Now what you have given here? You have given T half. You have given T half, and T half is what you have given? You have given T half. T half is 100 minutes. You have given T half. This is given to you. This is given to you, and you have asked how long it will take. और आप लोगों को पूछा है how long it will take to convert 90% reactant into the product. So in solution, it is a first order reaction. ठीक है? It is a first order reaction. This is given to you. It is a first order reaction. ठीक है? This is a first order reaction. So for first order reaction, T half is nothing but, for first order reaction, I will write here one more time, T half is nothing but 0.693 divided by K1. 0.693 divided by K1. This is the formula for first order reaction to calculate T half. So, and now here what you have given, T half is given to you, that is 100 minutes. If you put the values in this equation, T half is 100 minutes, then you can calculate the K1. Yes or no? Calculate कर सकते हो, नहीं कर सकते हो? ठीक है? So in this way you have to calculate. Put the values of T half. So 100 minutes you have written here is equals to 0.693 divided by K1. So K1 is equal to, if you rearrange this, then K1 is equal to 0.693 divided by 100, which comes 6.93 into 10 raised to minus 3. This is your K1. This is your K1. ठीक है? Yes or no? So it is in minute. It is in per minute. ठीक है? The unit for this is per minute. ठीक है? Yes or no? समझ का? First, अगर आप लोगों को T half दिया है, then by using that T half you have to first calculate the rate constant. you have to first calculate the rate constant, and here order of reaction is first order, and the formula for T half of the first order is 0.693 divided by K1. So by putting this value T half, you can find out the K1, and K1 is come 6.93 into 10 raised to minus 3 per minute. Now now uh, you have to calculate the unreacted concentration, that is A minus X. You have to calculate what you have to calculate, A minus X. Okay, now here A is, let us consider A is 100%, A is 100%, and आपको कैलकुलेट करना है at 90% complete. अगर रिएक्शन 90% complete हो गई तो how much is unreacted, 100 minus 90, so 10. So A minus X is 10. A minus X is 10. So 100 minus 10, because 90% रिएक्शन कंप्लीट करने के लिए अगर कंप्लीट हो गई, at that 90% completion of reaction, how much will remain unreacted, A minus X, and that is 100 minus 90 will come as a 10. ठीक है, then you have this equation for first order. K1 is equal to 2.303 divided by T log K A by A minus X. Now here A is how much, A is 100, A minus X is given, which is 10. So and K1 you know now, K1 is this much, 6.93 into 10 raised to minus 3, and what you have to find out, T you have to find out. What you have to find out, T. How long it will, time पूछा है ना आप लोगों को, तो T you have to find out. Just put the values of A minus X and K1 in this equation, you will get. Now I will write here, K is how much, 6.93 into 10 to the power minus 3, which is equal to 2.303 divided by T. This T you have to find out, into log of 100 divided by 10, into log of 100 divided by 10. Then 6.93 into 10 raised to minus 3, which is equal to 2.303 divided by T. So how much will left, log of 10, and log of 10 is 1. Log of 10 is 1. Please remember this, 10 का log कितना है, 1 है. So ये रह जाएगा 6, therefore 6.93 into 10 to the power minus 3, which is equal to 2.303 divided by T into 1, into ये आ जाएगा 1. अगर लिखा तो भी चलेगा, नहीं लिखा तो भी चलेगा, ठीक है. So into 1, because log of 10 is 1, because log of 10 is 1. Then you have to find out the T. So just rearrange this, so therefore T is equal to 2.303 divided by 6.93 into 10 to the power minus 3. Do this calculation and tell me the value. Do this calculation and tell me the value. 2.303 divided by 6.93 into 10 to the power minus 3. That will be your correct 332.20 minute. Correct, Rutik ne. So this is your time. This time, that is 333 we will round off 333 minutes. So as 90% of your reaction. So in after solving this equation, you have to write the reaction will take 333 minutes to get 90% completed. Reaction will take 333 minutes to complete 90%. ठीक है, in this way you have to solve. In this way you have to solve this equation. ठीक है, understood it? Any problem? Then we will go to the next one. Then we will go to the next. समझ ले का? Have you understood this? Yes or no? Only Rupesh Kumar is saying yes sir. What about others? Easy है, कुछ नहीं है इसमें. Just you have to remember the formulas. First, आप लोगों को क्या करना है? First, read the problem carefully, understand it, thoroughly, then write down whatever given to you, then identify the formula which is required to solve this problem. Once you have identified the formula, then write down this formula and see whatever given to you and what will require to you. then अगर कोई चीज नहीं दी तो आप लोगों को क्या करनी पड़ेगी, डिराइव करनी पड़ेगी. then if you have all the terms which are in the formulas, then put that values in the formulas, do the calculation, write down the minutes, you will get the 100% mark, you will get out of marks. and इसके ऊपर 100% प्रॉब्लम रहते ही एग्जाम में. आपको 10 या 15 मिनट्स के प्रॉब्लम रहेंगे इसके ऊपर, केमिकल काइनेटिक्स के ऊपर, तो आप लोगों को प्रॉब्लम अच्छी तरह से करनी है. ठीक है, अंडरस्टूड. ओके, देन वी विल गो टू द नेक्स्ट प्रॉब्लम, प्रॉब्लम नंबर 3. वी विल गो टू द नेक्स्ट प्रॉब्लम, दैट इज प्रॉब्लम नंबर 3. क्या है प्रॉब्लम नंबर 3? रीड इट केयरफुली. प्रॉब्लम नंबर 3 क्या है? रीड इट. फॉर अ गैसियस रिएक्शन, problem number 3, I will read it. For a gaseous reaction, 2Hi gives H2 plus I2. So first write down this reaction. क्या है reaction? Reaction is 2Hi, it gives H2 plus I2. This is your reaction. 2Hi gives H2 plus I2. This is your reaction. The half life period are 40 hours. Here next I will read. The half life periods are 40 hours and 10 hours when the initial concentration of Hi are 5 mole per liter and 20 mole per liter respectively. Calculate the order of reaction. Calculate the order of reaction. So you have to calculate the order of reaction. ठीक है, you have given the half life period and you have given the initial concentration. Now there are some formulas, there are some ways by which you can find out the order of reaction. And in this reaction you have given half life period, so you have to use the equation related to the half life period. आप लोगों को half life period दिया है, so you have to use the equation to find out order of reaction which has half life period terms. कौन सा equation है? Let us see in solution. This is the equation. equation आपके स्क्रीन पे है. This is the equation. ठीक है, ये इक्वेशन है हाफ लाइफ पीरियड का. This equation you have to remember. See here, log of t half 1 is given, log of t half 2 is given, log a2 minus log a1. So these equation you have to remember. So these equation you have to use, because in this equation t half term is there. Why this equation you have to use? Because in this equation t half term is there and you have to put the values of t half 1 and t half 2. So here t half 1 is 40 hours, t half 1 is 40 hours and t half 2 is 10 hours, and initial concentration, that is A, is 5 and A1 is 20 moles is given. You have to put these values, just these values in this equation, you will get the order of reaction. See, t half 1 is 40 hours, this is given to you. ये आप लोगों को क्या है? This is given to you. I will write here given, and these terms are given to you. T half 1 is 40 hours. See here, t half 1 is 40 hours, and at that t half A1 is that is initial concentration. A1 is nothing but initial concentration. Initial concentration of Hi. Initial concentration of Hi. So for t half 40, initial concentration is 5 mole per liter, and t half 2 is 10 hours. See here, t half 2 is 10 hours, and at t half 2 10 hours, A2 is given 20 mole per liter. A2 is given 20 mole per liter. So this is initial concentration of Hi at t half 1 and t half 2. ठीक है, and you have to put the values in this equation. You have to just put this value in the equation. ठीक है, so I will write down the values in this equation. ठीक है, क्या है? n is equal to, I will write here, n is equal to 1 plus, n is equal to 1 plus log of t half 1, and t half 1 is 40, so log of 40 minus log of t half 2. Log of t half 2 is 10, so log of 10 divided by log of a2. Log of a2 is 20, sorry, log of a2 is 20 minus log of a1. A1 is 5, so log of 5, so log of 5. ठीक है, so take the log of 40, 10, 20 and 5. Take the log 40, 10, 20 and 5 and tell me the value. So I will write here 1 plus log of 40. कितनी log of 40? How much is log of 40? Istisham, don't say 2. I know the order of reaction, but you have to solve step by step. We have to solve it step by step. Log of 40 is how much? Take the log of 40, log of 10, log of 20, log of 5. Log of 40 is 1.6020, correct. Log of 40 is 1.6020 minus log of 10 is, I have told you, log of 10 is 1, जो पहले एग्जांपल ने हम लोगों ने सॉल्व किया है. Then log of 20, how much is value for log of 20? Correct. Log of 10 is 1. Rupesh Kumar Istisham, very good. Log of 20 is 1.301, correct. 1.301 minus log of 5. Log of 5 is how much? How much is log of 5? 0.6989. 0.6989. ठीक है, this is log of. Now do this subtraction. ठीक है, I will do it in next. So 1.6020 minus 1, it will come. So here I will write n is equal to 1 plus, ठीक है, then 1.3010 minus 6989, कितना आ रहा है ये? Do it. .3010 minus 1.3010. So it will come correct. It will come 0.620. So if you divide this, it will come 1. So n is equal to 1 plus 1, that is n is equal to 2. So order of reaction is order of above reaction, n is equal to 2. N is equal to 2. In this way you have to solve the problem. In this way you have to solve the problem. ठीक है? Understood this, how to solve the problem? Yes or no? So with this I think we'll stop here. We have solved some problems. you practice at home. If you have any problem, if you have any problem, you can ask me. है कुछ problem? नो प्रॉब्लम्स, ठीक है. सो अगर किसी को कुछ प्रॉब्लम है तो यू कैन आस्क मी. आई विल गिव 5 minutes फॉर दैट. आफ्टर दैट आई विल एक्टिव द लिंक फॉर योर अटेंडेंस. गिव योर अटेंडेंस. Your attendance is very very important because for attendance 5 marks are there. No problem. Okay, it's good. अगर कुछ प्रॉब्लम नहीं है तो ये अच्छी बात है. ओके चलो. सो नाउ आई विल एक्टिव द लिंक फॉर अटेंडेंस. यू कैन गो एंड राइट द प्रेजेंट. ठीक है, नो प्रॉब्लम. शैल आई स्टॉप हियर नाउ? When will the practicals are going to start? नहीं आइडिया मुझे कोई भी, लेकिन विद इन दिस next week they will decide when to start the practicals. इसका डिसीजन अभी पेंडिंग है. नेक्स्ट 1 week में वो हो जाएगा. देन आई विल लेट यू नो. ठीक है, जब भी वो डिसाइड हो जाएगा देन आई विल टेल यू. अभी मैं कुछ नहीं बोल सकता. ठीक है. यस, एनी प्रॉब्लम? ठीक है, नो प्रॉब्लम. नाउ शैल आई स्टॉप? ओके चलो, बाय बाय, टेक केयर, हैव अ गुड डे.